Hello, this is the next video in a series I'm calling Fun Probabilities. And these are problems taken off actuarial exams, and specifically off the list that I have, the playlist that I have called Free Actuarial Exams. So let's just start. Person X, Y, and Z in order roll a die. The first to roll an even number wins. Find the probability that X wins. So the answer is this. Let's let X be... Ooh, that X is not this X. I wish I was used a different letter. So this is random variable X, that's person X. So let random variable X be the number of rolls until an even is observed. So X goes from 1 to infinity. Note that person X rolls on 1, 4, 7, 10, right? Because they go in order. Now the probability that random variable X equals little x, so that's say that the probability that we roll an even number on the 10th roll is this. And so we roll odd numbers, which it has a probability of half, 9 times, or x minus 1. And the probability that we roll an even number, or 1/2, is this. But since they're both 1/2, we can combine them in just a 1/2 x. So now note that when person X rolls, so in order for person X to win, then we need this random variable X to be 1, 4, 7, 10, etc. So it's a probability that X equals 1 or 4 or 7. And since this is the probability mass function, then we just put in 1 here like that. And then since it's or, it means plus. So then we put a 4 there, and then a 7, then a 10, and etc. Now, this is a geometric series, and so and the variable is less than 1, so this does converge. And the way my mind thinks is I like to have a 1 here, and then the rest, then it's to the and then it's to certain powers. But these powers don't go in order, so we have to do something. So I factor out a 1/2, and then we get 1 plus 1/2 to the 3rd, 1/2 to the 6th, 1/2 to the 9th. But we could take each of these, have a factor of 3. So let's put that factor into the 1/2. So then we have 1, and then we have 1/8. And then we have 1/8 squared, 1/8 cubed, 1/8 to the 4th. And now this is in that geometric series that I understand how to calculate. So then this converges to 1 over 1 minus 1/8. And of course the 1/2 out front. And this simplifies to this, which simplifies to 4/7. So that's the probability that X wins. Next problem, a die is converted into a biased die in which the probability of a given number is proportional to that number. So in 6 rolls, what is the probability that each face appears once? So here's the answer. So let's let Xi be the number rolled on the ith roll. So the probability that Xi equals J, so remember J is 1 through 6, it would be equal to J over 21 because the sum of 1 through 6 is 21, and since each number is proportional to the number rolled, then all these will add to 1. So that's the probability. So now for a specific case, and I'm going to make this up, x1 equal 1, x2 equal 2, all the way to x6 equals 6. So each number is represented once. So the probability that we roll a 1, probability that we roll a 2, all the way to the probability we roll a 6 is equal to, the product of those, which is 6 factorial over 21 to the 6th. But note that if we put these in a different order, but have each number once, it's actually this same probability. These products will be rearranged, but it's the same probability. So really, we just need to figure out the number of orderings of 1 through 6. which is 6 factorial, right? Because if any number, how many numbers can we put here? 6 of them. But then how many numbers can we put here? Only 5, because we used one there. And then it's 4, 3, 2, so it's 6 factorial. So the probability that each face appears once is the number of ways, which is 6 factorial, times the probability of an individual case. And then that simplifies to 6 factorial squared over 21 to the 6th. Now, problem 3, a die is rolled 3 times, and the outcome is represented by x1, x2, x3. We want to find the probability of this ordering. x1 is less than or equal to x2, which is less than or equal to x3. So the way that we're going to calculate this is it's the number of ways that we can have this ordering divided by all possible possibilities. So since each possibility has 6 possible outcomes, it's 6 cubed is the number of possible ways, which is 216. Now we don't know how many orderings that fit this category yet, so let's figure it out. So here, and to simplify it, let's just put x1, let's say we roll a 1 on the first case. Then there's 21 ways that x2 and x3 can happen that fit this criteria. If x1 were a 2, then there's 15 ways. You know, x3 could be a 2, x2 could be a... So this is not 100% correct. So this is that these are all x1. And it's a way to order them. So if the first outcome's a 2, then there's 15 ways that we can meet this criteria when the first roll is a 2. When the first roll is a 3, then there's 10 ways that we can have this ordering. When the first roll is a 4, boy, did I booger this up. Then there's 6 ways that this can happen. If the first roll is a 5, then there's 3 ways. And if the first roll is a 6, then there's 1 way, right? Then the second roll has to be a 6 and the third roll has to be a 6. That's the 1 way. So if we add up these number of ways, we get 56. So the probability is 56 over 216. And sorry about this notational error. So problem 4, and we have 5 dice are tossed or rolled. What's the probability of a full house? That's 2 of a number and 3 of another number. And here's the answer. So let's look at a specific case. So let's say 2 die, die I and die J equal number A. And then K, L, and M, the other 3 die equal B. Since each of these die are independent, the probability that die I is A is 1/6, so it's 1/6 to the 5th. And I write it generically like this because when you roll all 5 die, it could be the 2nd and the 4th equal the same number, and then 1, 3, and 5 equal the other number, right? So there's different possibilities. But how many ways, so the important part though, in each specific case, the probability of that particular outcome is 1/6 to the 5th. So that means we just need to find out how many possible ways it can happen. So the number of ways to choose 2 die to equal is combinations 5 choose 2, which is 10. So after we choose 2, then the other 3, there's only 1 way for them to be equal. That's, they have to all equal. But then how many ways can we choose A and B? Number of ways to choose A and B is permutation 6 choose 2, which is 30. And the reason is it's not combinations, because if we switch A and B 2 die equal to B and 3 die equal to A is not the same as when you flip them. So it's order matters, so it's permutations. So the probability of a full house is combinations 5 choose 2, permutation 6 choose 2, times the probability of an individual event, and then that simplifies to 50 over 6 to the 4th. Now the 5th problem, 2 die are rolled. What's the probability of a 7 before an 8 is rolled? So let's let xi be the number on the ith roll, right? So, and since any given roll is independent from the other, they're the same. So the probability that the ith roll is a 7 is 1/6, right? 6 over 36, which reduces to this. Now the probability on any given roll that it's an 8 is 5 over 36. So the probability that xi is not a 7 or 8 is 1 minus the probability that it is a 7 or 8. And so it's 1 minus 3 over 36. I mean 11 over 36, right? Because or is plus, so it's this plus that. So this is 6 over 36, 5 over 36, 11, 36. So that's 25 over 36, probability that we do not roll a 7 or an 8. Now, the probability on the ith roll that we roll a 7 and not a 7 or 8 on the previous I minus 1 rolls is this, right? So the probability that we don't roll a 7 or 8 on the previous rolls is 25 over 36 raised to the I minus 1. And then we roll a 7 on this roll is 1/6. But that's the ith roll. But this can happen for any I. So the probability that we roll a 7 before an 8 is the sum of these probabilities. So this, I call this PI. So from I equals 1 to infinity of PI. But PI was this, right? But this, if we factor out the 6th and then enumerate these, we get this, which is a geometric series. And this converges to, 1/6 times 1 over 1 minus 25 over 36, which then this simplifies to 6 over 11. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.